Science is totally based on concepts. We observe specific orders in the environment, analyze them, and having collected the common attributes and principles of them, we build concepts. Students study these concepts and engage them in their science education. But everyone can know them. The point is to understand. So I'd like to begin a new video series explaining the reasons for these concepts and describing how they've been formed and what they are for. Earlier in this channel, we introduced you a few concepts and the reasons caused them. One is about images. Another one is about weight. Anyone who watched them must have understood that the reality of these scientific concepts is not what we see looking at their surfaces. Hence, in this series, I'm gonna travel to their depth and reveal their real nature. Come and enjoy Art Science, which touches the artistic places of science and makes people informed. I thought to start the series with a simple but essential concept we meet in mechanics. So today I'm gonna introduce you the concept, center of gravity. Let's see what it is. This is a wooden pole. I try to balance this engaging one finger underneath it. I start from one corner. After a very hard toil, I could come to a specific point where I can balance the pole from. This could be either its center or somewhere else. This point is called the center of gravity of the pole. How could this be the center of gravity of the pole? That's the major opinion of this video. First of all, shall we consider the definition of the center of gravity? Okay. The point where its center lies, the weight of all the particles of an object is defined as its center of gravity. We can consider that the entire weight of this object executes from there. Here, the weight is the gravitational force exerted by the Earth on the object. It's more suitable if you're informed what the weight really is. For that, please watch our video on Does Our Weight Get the Same Number Wherever in the World? An object is considered to be made of an infinite number of particles. Having added all the pieces of weight of every single particle, the entire object owns a weight. But I told you this whole weight executes from the center of gravity. What's the idea expressed here? Is it the real truth? No. It's merely a concept. Let's see how this concept gets built up. These are the particles which an object is made of. Every particle has a unique weight as this. This is the center of gravity of the object. You know that any force makes a moment around any axis. What we measure through this moment is how large the influence made by the force to rotate the object around that axis is. I consider an axis goes through the center of gravity. The weight of every particle tries to rotate the object either clockwise or counterclockwise around this axis. Then pay your attention very well to what I say now. We choose the center of gravity of an object as this requirement to be fulfilled. The moments made by each particle around any axis which goes through the center of gravity must be balanced by each other, as the object should be still without any rotation. Saying in other words, the resultant moment around any axis by the weight of the object should be zero. The moment of a force is calculated using this formula. It's equal to the product when the size of the force is multiplied by the perpendicular distance from the force to the axis. Therefore, if a non-zero force makes no moment around a particular axis, it tells that this very force executes through this axis. So there's no perpendicular distance. That's why I said that the whole weight of the object executes through its center of gravity. Then there wouldn't be a perpendicular distance between the force and the axes. Then I'll introduce you some practical instances to get this well explained and proven. I take the previous wooden pole. Using the aforesaid method done with finger, I find its center of gravity. Then I take a string, tie it here, and hang the pole. The pole is made of particles. The weight of these particles tries to rotate this clockwise. These forces try to rotate this counterclockwise. These moments are similar in size, and so that they balance each other. Hence we say that the center of gravity of this pole is here. Why is that? Look at this very well. To achieve the equilibrium of an object on which two forces are engaging, those couple of forces should be similar in scale and opposite in side. Also, those forces should be collinear. Therefore, the tension of the string should be similar to the weight of the pole. As well, they should be collinear. That's why the center of gravity is situated here, where all the moments are balanced around. This bird has achieved equilibrium on this pointed end. Then what can we decide? The center of gravity of the bird is situated on its beak. So the moments formed by every part of its body around every axis which goes through the beak are balanced with one another. What would have happened if these wings hadn't spread until having surpassed the beak? Then the equilibrium around this axis would break and the bird would fall down. So there must be masses having spread around the center of gravity of a system. A corner of a system cannot be its center of gravity. This is the idea I try to express through introducing the center of gravity as where the weight of every particle of an object is centralized into. There's another concept we've built up, called the center of mass. What's that? Let's find out about it. The place where all the masses of a system have been centralized is called the center of mass of the system. How could we find that place out? We can't describe this concept using practical instances as we did previously for the center of gravity. Cause the mass and the center of mass of an object are merely theoretical concepts used in calculations related to physics. What does it mean? Mass of an object is only the value it comes when its weight is divided by the gravitational acceleration. Otherwise, it's not a real quality of an object. So the center of mass has only got a theoretical way for defining itself. This is a system of masses spread in the free space. I take one standard point as the root point. I name these masses as M1, M2, M3 and so on until Mn. I name these horizontal distances as x1, x2, x3 and so on until xn, and these vertical distances as y1, y2, y3 and so on until yn. I assume that here is the center of mass g, and these distances are x bar and y bar. The whole mass of the system is considered as capital M. I can define x bar and y bar as this. X bar equals m1x1 plus, m2x2 plus, m3x3 plus so on plus mnxn, divided wholly by capital M. Y bar equals m1y1 plus, m2y2 plus, m3y3 plus so on plus mnyn, divided wholly by capital M. According to these two formulae, we can find where the center of mass takes place. But what is the method of building up these formulae? Let's see. These masses have their own weight as this. Since all the masses of the system have been centralized into the center of mass, the moment the weight of the system forms around any axis should be equal to the sum of the moments formed by each individual mass around the particular axis. I'll consider an axis which goes through the root point. So capital M, x bar g is equal to m1x1g plus, m2x2g plus, m3x3g plus so on plus mnxng. And capital M y bar g is equal to m1y1g plus, m2y2g plus, m3y3g plus so on plus mny and g. Cut off g from either side. Divide both sides by capital M and then it comes our formulae. But this is the way of finding the center of gravity. So both the center of gravity and the center of mass of an object should locate at the same place. But actually, there's a slight difference between the center of gravity and the center of mass of the same object. According to the Newton's formula we introduced you in the video in which we discussed about weight, the gravitational forces exerted by the Earth on the nearby particles of the object are greater than them on the distant particles. Cause the lesser the R, the greater the F. So the weight of nearby particles, and as well as the moments they form, are slightly bigger. Hence the center of gravity of an object is situated very slightly downwards to its center of mass. But, when compared to the distance between the Earth's crust and center, any object is extremely smaller. So we can consider that all the distances from Earth's center to every single particle of an object is similar in size. So their weight is similar and the center of gravity coincides with the center of mass. To sum up, although we define the center of gravity as where all the weight of every particle which an object is made of is centralized, it's where the particular axis travels through around which all the moments are balanced with one another. This phenomenon has been symbolized by the concept center of gravity, and we use it for our purposes.
Thank you for watching this video. If you gained something from this video, don't miss to like it and share it. Subscribe my YouTube channel for more video like this. Click the bell icon for getting a notification about my channel. See you again.